Okay, good morning, students. Today's chapter is chapter 9, topics metallic bonding, subject chemistry. 9 BC you are not. Okay, this metallic bonding. You know this bonding from non-metal metal, ionic bonding, and non-metal covalent bonding, and metal ionic bonding. Ionic bonding is formed among metals. Here metallic bonding, this is sodium is a metal. When sodium atoms bond together to form the solid metal, the outer electron on each sodium atom becomes free to move throughout the whole structure. The electrons are said to be delocalized. These electrons are no longer attached to a particular atoms or pairs of atoms. Instead, you can think of them as following around through the whole metal. When a sodium atom loses its outer electron, a sodium ion is left behind. A metallic structure consists of a lattice regular arrangement of positive ions in a sea of delocalized electrons. So here, when a metal lost electrons and become positive ions, these electrons, losing electrons, move throughout the structure. It will not stay in one ions. It moves throughout the structure. That means the positive ions in the sea of delocalized electrons. Here, a metallic structure consists of a lattice regular arrangement. Look here. This 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is the regular array. It is called lattice. A regular arrangement of particles is called lattice. So structure consists of a lattice of positive ions in the sea of delocalized electrons. So here, attraction between sea of delocalized electron. Have you seen sea of delocalized electron? This is sea of delocalized electrons. This is lattice of metal ions. It is one positive because sodium lost one electrons. Lost one electron, so one positive. If metal lost two electrons, it will be two positive. Here, if lost three electrons, it will be three positive, so on. So here, sodium lost one electron, so it becomes one positive charge. So what is metallic bonding? We know this metallic bonding is the electrostatic forces of attraction between each positive ions and delocalized electrons. So what is the metallic bonding? Metallic bonding is the electrostatic attraction forces among delocalized electrons between each positive ions and delocalized electrons. This holds the structure together. Okay, say what is metallic bonding?
Metallic bonding is the electrostatic forces of attraction between positive ions and delocalized electrons.
Each positive ions and delocalized electrons. Thank you, done well. Excellent. So metallic bonding done. The ion formed by the metal depends on the number of electrons. Okay, number of electrons the original atom has in its outer shell. Okay, outer shell. Thus the elements in group 1 form 1 positive ions. All the elements in group 2 form 2 positive ions. So ions formed by the metal depends on the Number of electrons in the original atom has in its outer shell. Outer shell, how many electrons present? We know group 1 metals all has 1 electron in the outermost shell. Lithium, sodium, potassium, rubidium, cesium. So they will form 1 positive ions. And group 2 elements, beryllium, magnesium, calcium, they have 2 electrons in the outer shell, so they form 2 positive ions. So group 1 metals form 1 positive ion because they have 1 electron in the outermost shell. For example, sodium, group 1 elements, 281. This look at outermost shell, 1 electron. So it has 1 electron in the outermost shell, it loses 1 electron and form 1 positive ion, Na plus. Group 2 metals form 2 positive ions because these have 2 electrons in the outermost shell. For example, magnesium, 282. It has 2 electrons in the outermost shell, it loses 2 electrons and form 2 positive ions like magnesium 2 plus. Okay, which ion is formed by aluminum? Which ion would form by aluminum? Check which group aluminum and say which ions will be. Which ions?
Group 3.
Huh? 3 aluminum 3 plus. So you write 3 okay, the diagram, 2D diagram of group 1 metals and group 2 metals. Look, this is the left hand side of the picture. This is the 2D diagram. 2D means 2-dimensional diagram of group 1 metals and 2D diagram of group 2 metals. 2D means 2-dimensional, here only width and height, and 3-dimensional means width, height, width, breadth, height. Here 2D is width and breadth, and if 3D it will be width, breadth and also height. Okay, here only 2D diagram. We take the pictures now present nowadays also 2D diagram. In the future we will see the 3D diagram pictures, 3D television. Okay, leave it. This nucleus, group 1 metal, all form 1 positive charge, so 1 positive charge. You give this the regular array, 1 2 3 3 3. Then C of delocalized electrons. You can give C of delocalized electrons. Okay, it will be, should be same number electrons. 9 positive charge, so 9 electrons. Don't give more. Okay, try to understand it. So here this is the 2D diagram of group 1 metal. This is the 2D diagram of group 2 metal. You can write all metal, beryllium, magnesium, calcium, all is 2D. Yay! It is also 2D. This here 1 2 2 1 2 1 2. Draw 2D diagram for magnesium metal and submit to my WhatsApp number.
এগুলা এই যে মেটাল আয়নসের কি কোনো পার্টিকুলার নাম্বার থাকে?
What?
যেমন এতগুলাই দিতে হবে না যে কোনো নাম্বার?
I didn't understand. Please say again.
The particular নাম্বার থাকে, যেমন ফার্স্ট অ্যারেঞ্জমেন্টে 3টাই দিতে হবে অথবা ফার্স্ট অ্যারেঞ্জমেন্টে 4টাই দিতে হবে।
Particular number of ions. Okay, this you can give
Yes,
3. You can give 3 4. It is not problem. You give 3 or 4, no problem.
Okay, sir.
Okay, now metals conduct electricity. Metals conduct electricity because the delocalized electron are free to move throughout the structure. Okay, metals conduct electricity. Why? Metals conduct electricity because the delocalized electrons are free to move throughout the structure. Okay, Imagine what happens if a piece of metal is attached to an electrical power source. If you imagine a piece of electric source is attached to the a piece of metal, and electrical power source is attached to a piece of metal. So what happened here? Electrons are moving. This is the source of electrical power. This is both is source of electric power. This is the positive and negative end. Hey, so this total is a source of an electrical power source. Hey? Like battery, two end, positive and negative end. So the from negative end to positive end, electrons are moved towards from negative ends to positive ends. Look, have you seen the direction? Electron attached to this end by the positive terminal of the power source and then flow away along the wire. More electrons flow along the wire from the negative terminal of the power source to replace those moving away in the metal. So here, why metals contact electricity? Metal contact electricity because the delocalized electrons are free to move throughout the structure. Okay, metals are malleables. Can be broken easily and can be shaped. Give the different type shape. Metals can be hammered into different shape. This is what the word malleables. Metals can be give different type shape. Malleables. We take this metals spoon one kind shape and like tin house, tin made tin. This is different type shape can be given because metals are malleable. Metals can be hammered into different shape. So metal malleables. Malleable means when we apply a force to a piece of metal, the layer of positive ions, slide over each other. If we give the force, this one becomes slide over each other. For this reason, metals are malleable because when we apply force to a piece of metal, the layers of positive ions slide over each other. This is, you may remember this, the layer of positive ions slide over each other. These things come question. Have you seen these things? We'll be able to draw. Will I show drawing? Is it necessary or not?
No, sir.
Don't need. Okay. You'll be able to drawing. Now metals are ductile. Metal can also be described as ductile. This means that they can be drawn into wires. Hey, look, these wires. This explanation is the same why they are malleable. Okay, explanation is the same why they are malleable because when we apply force, a piece of metals slide over each other. Okay, this copper conductor, plastic conductor over copper wire. This can be can turn into wire. For this reasons, metals are ductile. Evaluation: which ion is formed by calcium metal? Which ion is formed by calcium metal? Everyone should unmute and give my question answer. Which ion is formed by calcium metal?
Positive.
I know positive. So which ions is formed by calcium metal? Mg2 plus, Mg plus, Mg Ca plus, Ca2 plus.
Ca2 plus.
Good. Okay, why sodium metal conduct electricity? Sodium metal conduct electricity because delocalized electron which move throughout the structures.
Free to move.
Okay, next topic is nothing. So here finished. Thank you for joining today's class. I'll give homework.